Good morning, students. We'll start with the today's lecture. This is the last topic what we are going to study in this chapter. That is Nyquist plot. That is assessment of relative stability using Nyquist criterion. Right. Based on this, we'll solve few numericals. Already we have seen several numericals on the Nyquist plot, right? And how to judge the stability, all those things, and we have seen. And how to determine the range of values of k for stability. That also we have seen. Then last topic today is assessment of relative stability using Nyquist criterion. Then we'll see the numericals, how to get the value of k or to find the value of k when gain margin is given or phase margin is given, right? That those numericals we will see. Okay, this topic we will be first we should know what is relative stability, and before this we already know this what is absolute stability and what is relative stability. In absolute stability means this in absolute stability, yes or no answer means whether the system is stable or unstable. Yes or no answer will come, right? It is right. Already given the difference between absolute stability and relative stability, right? Okay, it is quantitative measure of stability and this is qualitative. Quantitative measure of stability means yes, whether the system is stable or unstable. It is clear cut answer we will get in the absolute stability. Whereas in relative stability, system is already stable. There is no question of instability at all. System is already stable. To what extent or to what degree the system is stable, whether it is less stable or more stable, that only that matters here in relative stability. Relative stable systems are already stable systems only. Please keep in the mind. Relative stable systems are stable, but to what degree or to what extent the system is stable, whether they are less stable or more stable, only question that remains, right? And we can judge the relative stability of the system by looking at omega gc, omega pc, gain margin and phase margin. So these are the parameters. Already we know what is gain crossover frequency omega gc, phase crossover frequency omega pc, gain margin and phase margin. Okay, yes, we know the stability conditions. Omega, whenever omega gc is less than omega pc, gm and pm are positive. Gm and pm are positive and system is stable. This we know, right? Then second condition, whenever omega gc is greater than omega pc, gm and pm are negative, system is unstable. Third condition, we already know this, just I am listing out. Whenever omega gc is equal to omega pc, gain margin and phase margin are 0 and system is marginally stable. These stability conditions we know, right? Okay, what is the meaning of this gain margin and phase margin? Let me take this stability condition. System is already stable. We will concentrate only on the first condition because we are studying the relative stability means system is already stable, right? We'll consider only the first one. So GM and PM are positive means let me take gain margin is 10 decibels for example. Okay, then phase margin is plus 38 degrees, something like this. Okay, what is the indication? Means these are the allowable gain values till the system reaches on the verge of instability. Means yes, 10 decibel is allowed, right? Whenever means till 0, okay, gm is if it goes to negative means system will become unstable. Means till 10 decibels, right? 1 to 10 decibels, this is the allowable gain values, so that the system will be in the stable condition, right? But if it is 10 dB, system is more stable. If it is 5 dB, for example, then system is less stable. If it is 1 dB, system is less stable. That's all, right? So these are the allowable values of the gain till the system reaches on the verge of instability. These conditions we have defined. What is gain margin? Similarly, with respect to phase margin, for example, let me take plus 38 degree. It is positive value. Means these are the values of the phases that are allowed till the system reaches on the verge of instability. For example, plus 38, system is stable. If it is plus 20 degree, system is less stable, but it is stable only, but less stable. If it is plus 5 degree, system is less stable, right? I hope you are getting what I mean to say. So this is the relative stability. Then we can analyze the relative stability of a closed loop system by looking at the Nyquist plot or polar plot. Polar plot is the basis for Nyquist plot, right? Okay, whether yes, we know the Nyquist stability criterion n equal to minus p. This is the Nyquist stability criterion, right? If none of the poles are lying in the right of the S plane, P is 0, because for the system to be stable, none of the poles should be in the lying in right of S plane, right? So n should be equal to 0 is the stability condition. If n is 0, means what is the indication of this? The Nyquist plot should not encircle -1 plus j0 critical point. If it does not encircle, then system is stable. I hope you are getting right. Okay, then what is the information we are getting? We'll see. As the polar plot, just I underlined here. As the polar plot gets closer to this critical point -1 plus j0, the relative stability reduces and the system tends towards instability. Okay, just in the next slide I have, you can answer here. So I have system A and system B. System A, the complex conjugate roots are located here, right? Similarly, the complex conjugate poles, poles are located here. Can you tell which is more stable? System A is more stable or system B is more stable? Can you answer? Please answer. Which is more stable? System, huh? Yes.
A.
System A is more stable. Yes, system A is more stable. System A is more stable. And system B is, it is stable but less stable as compared to system A. Less stable. But both are stable systems only, right? Why? Because you can observe here the complex conjugate poles are situated far away from the imaginary axis. Just observe in second case system B, the complex conjugate poles are near to the imaginary axis. This is one analysis. And another thing just now I told, as the polar plot gets closer to -1 plus j0 point, the relative stability reduces. We can observe the for system A, this is the polar plot or Nyquist plot, right? Polar plot, okay? For system B, this is the polar plot. You can observe here. You can observe this is the polar plot, right? And point is here -1 plus j0. In the first system B, this is the polar plot, and this you can observe here the polar plot is very much nearer to this -1 plus j0 point as compared to the system A. It is far away as compared to this. Let me take this like this. Is it fine? Let me take it like this. So as the polar plot reaches near to the critical point, the system becomes less stable. As the polar plot is far away from the critical point, system will be more stable. I hope so. By two analysis, just by looking at the location of the closed loop poles, whether they are situated close to the imaginary axis or far away from the imaginary axis, we can judge the relative stability of the system. And by looking at the polar plot or Nyquist plot, whether it is near to critical point or far away from the critical point, based on that we can judge the relative stability of the system. Relative stability means whether it is more stable or less stable. So system A is more stable as compared to system B. I hope you have understood this, right? If any doubts, you can unmute yourself and talk to me so that I can clarify your doubts. Okay, we will be solving 2 or 3 numericals and we will wind up this chapter. Okay. 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 Before starting with this, I want to give you some formulas, right? What is gain margin? Okay, I have some space here. Okay, let me write here only. Okay. What is gain margin? Formula 1 by magnitude of g of j omega into h of j omega at omega equal to, for gain margin we make use of phase crossover frequency, but omega equal to omega pc, right? In decibels, 20 log of this quantity, right? But we know the Nyquist plot or polar plot, 1 divided by magnitude of this is nothing but magnitude of O to Q. Q is intersection of polar plot with the unit circle. This I hope you remember. Just let me draw it here. I hope you remember this. Okay, just let me draw it here once again. Let me draw the unit circle first. Already I told you, but once again I am recalling for you people, that's all. This is the unit circle. -1 plus j0 point is here. Unit circle means -1 plus j0 will be here only. -1, this is right. -1 plus j0. Here it is. Okay. The polar plot can go like this, or for stable systems means it has to come inside only for stability. It should not encircle. The polar plot should not encircle. Right, this point. The polar plot is intersecting this unit circle at point Q. Yes, sorry, P. This is P. And the polar plot is intersecting negative real axis at Q. This we have seen, right? Yes, this if you remember sigma j omega. This is 0 degree, -90, -180, -270. Whenever the polar plot intersects the unit circle, this will give me point P. What is this? It will give me omega equal to omega GC, gain crossover frequency. Whenever the polar plot intersects the negative real axis, that is minus 180 degree line, it gives the point Q, and it gives the frequency, corresponding frequency is phase crossover frequency, omega equal to omega PC. I hope you remember this, right? Okay. Then at omega equal to omega PC means this distance, this origin O to Q, right? So it is 1 by magnitude of OQ. If I want in decibels, in dB, gain margin is equal to 20 log of this quantity. You can write this or this one and the same. 20 log of 1 by magnitude of O to Q, right? This is in decibels. Next, similarly, we know the phase margin formula. Just I will recall. It is 180 degree plus angle of J of j omega and H of j omega at omega equal to omega GC. We make use of gain crossover frequency, right? So this is the formula. You have to remember this formula and this one. So based on the gain margin and phase margin formulas, we can solve these problems, right? Okay. The open loop transfer function of a system G of S is equal to K divided by S into 1 plus 0.1 S into 1 plus S. Determine the value of K so that the gain margin is 6 dB. We have to determine value of K, right? So we will write whatever it is given to us. G of S is equal to K divided by S into 1 plus 0.1 S into 1 plus S. This is given. We want to determine the value of K, and gain margin is given. It is given in decibels here, 6 dB. Okay, we will try to find out the value of K by making use of this data, right? Gain margin is 6 dB, right? How to find out, we'll see one step by step. So what is the formula for gain margin? Just now I have written gain margin is equal to 1 by magnitude of OQ. 1 by magnitude of G of j omega into H of j omega at omega equal to omega GC, one and the same. Either I can write. Okay. Let me write that also, no problem. It is 1 by magnitude of G of j omega into H of j omega at omega equal to omega PC, phase crossover frequency. This is nothing but 1 by magnitude of OQ. In decibels it is, in dB, gain margin is equal to 20 log of this quantity or this quantity, one and the same, right? Let me take this 1 by magnitude of OQ to the base 10, right? Call this as equation 1. So gain margin is given. So now I want to find out the intersection point Q. Here, this point Q, where the polar plot or Nyquist plot is intersecting the negative real axis. So in order to find out this, we have to find out omega equal to omega PC also, right? We'll see. So we know that how to find out omega PC mathematically, that we know, right? We'll try to do that. So first we'll try to find out the omega PC first. Determine omega PC mathematically. We know the steps, right? Okay. So first replace S by j omega, convert it into frequency domain, G of j omega. H of S is not given means it is unity. H of S is 1, right? If you want, you can write H of j omega. K divided by, replace S by j omega everywhere. 1 plus 0.1 j omega, 1 plus j omega. Okay, first we have to rationalize it because we know the steps how to find out omega PC, right? Then we'll find out the intersection point. Okay, determine omega PC mathematically and intersection point Q. Intersection point. Intersection point of Nyquist plot with negative real axis. That is nothing but the point Q, right? So this we'll try to find, so that I will get this, right? Magnitude of OQ. So j omega means minus j omega. 1 plus 0.1 j omega means 1 minus 0.1 j omega. 1 plus j omega means 1 minus j omega. Rationalize it. Sorry, I have to take the same thing, minus j omega. So 1 minus 1 minus j omega If I'm making mistakes, please correct me, right? Okay, j of j omega equal to, let me take numerator, so I'll be changing the ink color. Let me do the rough work here only. First I will multiply these two. 1 into 1 1, numerator I'm doing. 1 into 1 is 1. 1 into minus j omega is minus j omega. Minus 0.1 j omega into 1, minus 0.1 j omega. Minus into minus, it is plus, but it will become minus because j into j is j square, that is minus 1. Minus into minus plus, plus into minus minus. So j square, we have taken 0.1 omega square. 0.1 omega square. So this is over. So but this minus j omega have to, these two things have multiplied. So let me write it what I am getting. 1 minus 0.1, this is real part. 1 minus 0.1 omega square. Then next point minus 1 minus 0.1, so minus 1.1 j omega. So these two terms I got, just multiply minus j omega into this k, minus j omega k, multiply minus j omega k, this one k into minus j omega, multiply it. So minus j omega k minus minus into minus, it will be plus. So 0.1 j omega cube k, right? Yeah, I hope it's correct, right? Minus into minus plus, but j into j is j square is minus 1, so minus into minus plus, once again it will get minus. So omega square k, omega into omega square k, this is fine. Numerator, this is entire numerator. So let me separate into real part and imaginary part. So this is real part, minus omega square k, right? Then imaginary part, these two things. So we'll take j omega common, j omega k plus j omega k, right? J omega k is taken common. So j omega k means 0.1 omega square, I will get 0.1 omega square. I hope it is correct. Then j omega minus 1. Any mistake, you please let me know. Okay, this is fine. Okay, numerator is over now. Next, we have to simplify the denominator. So denominator will multiply here. So first I will multiply j omega into minus j omega, j omega into minus j omega. So plus into minus minus, but j square is minus, so I will be getting plus, so I will be getting omega square. Next I will multiply 1 plus 0.1 j omega into 1 minus 0.1 j omega, a plus b into a minus b, a square minus b square, a square minus b square, 0.1 j omega whole square, sorry, a plus b into m, correct, 0.1 j omega whole square, because a plus b into a minus b, right? A square minus b square, this entire thing, right? So what I will be getting, let me write it. So 1 j square is minus 1, so it will become plus. So 0.1 square, what is 0.1 square? Let me calculate it. 0.1 square, 0.1 square is 0.01, so 0.01 omega square. So this first term, these two I have multiplied already, so I am getting omega square from it. From these two I have multiplied, I am getting this. Then we will multiply these two. 1 plus j omega into 1 minus j, a square minus b square, a square minus b square, j omega whole square, right? 1 j square is minus, so it will become plus 1 plus omega square. So denominator, what I will be getting? So this into this into this, right? So I will be writing here, separating real part and imaginary part. So minus, this is real part, right? Minus omega square k, minus omega square k plus j omega k into 0.1 omega square minus 1. This is numerator we have written, divided by the denominator, omega square into 1 plus 0.01 omega square into, okay, this is over, then 1 plus omega square. Okay, this is the real part, this divided by this. Okay, you can separate it and write it directly, right? J of j omega, we'll separate and write it, minus omega square k divided by this denominator. So let me call this denominator as d. Is it fine? Or else, okay, no problem, let me write it. Minus omega square k divided by omega square into 1 plus 0.01 omega square into 1 plus omega square. So this is the real part. So let me write the imaginary part, plus j omega k into zero point 0.1 omega square minus 1. 0.1 omega square minus 1 divided by this denominator. Omega square into 1 plus 0.01 omega square into 1 plus omega square. So this is the real part and this is imaginary part. So equate imaginary part to 0. This entire thing should be equated to 0. If I equate this to 0, this denominator will go that side and it will become 0. I am left out with only this thing. So equate imaginary part to 0. So which implies, so this denominator will become 0. So I am left out with only this numerator part in the imaginary part, omega k into 0.1 omega square minus 1 equal to 0, because this will go off, right? So which implies omega equal to 0, right? But omega k equal to 0 means omega equal to 0. Then 0.1 omega square minus 1 equal to 0, right? So 0.1 omega square minus 1 equal to 0 means plus, it will, if this goes that side, it will become 1, right? So we will calculate omega here. So omega square equal to 1 by 0.1 is 10, right? So here omega equal to omega pc, because whatever we are calculating is phase crossover frequency, right? That is equal to root 10. So let me write what is root 10. So 3.162 radians per second. So we have found out omega pc. Then if we want to find out the intersection point q, right? This one. So substitute in real part. Substitute omega equal to omega pc, that is equal to root 10 in real part. So we will take real part. So I will write down this. This is the real part, entire thing, right? So minus omega square k divided by omega square into 1 plus 0.01 omega square into 1 plus omega square. So at omega equal to omega pc, that is equal to root 10. So I am getting omega square everywhere. So omega pc square is nothing but 10, right? So let me write it. Omega pc square is nothing but 10, because omega pc is root 10. Omega pc square is 10. So I'll substitute here. So minus omega square is nothing but 10. 10k divided by omega square is 10. And this is omega square is 10. 10 into, let me multiply and write it. 10 into 0.01. 10 into 0.01. So 0.1 plus 1. I will add this plus 1 also. Plus 1. So I am getting 1.1. Let me write it here. 1.1. Let me substitute here. Oh, it is 10. 10 plus 1 is 11. Is it fine? So 10 will get cancelled. So finally I will be getting minus k divided by, so 1.1 into 11. 1.1 into 11. So 12.1 I am getting. I hope I have not made any mistake, right? Okay, this is what the coordinate of point q. We have to determine k still. It is not yet over, right? Whether I have done some any mistake, please correct me if I have made any mistake, right? Or else it's correct, I think. Yes. Any mistake is there? But let me cross verify here. 1 divided by 12.1, how much I will get? So 0.08. So I think I am not getting the required answer, I think. Anywhere I have made a mistake, can you?
Yes, sir.
Yes, tell me.
Sir, in numerator it is minus 1.1 omega square k.
In numerator minus 1.1. 1 minute, just let me check it. This one?
Yes, sir.
1.1.
Real part is minus 1.1 omega square k.
Minus 1.1 omega square k. Here I have made where I have made a mistake. I am not getting. Let me check it here. Let me correct it. 1 minute. This one I think. Last one I have left. I think, right? Let me check it. Minus j omega, fine. This is fine. Omega square k, but I have left here. See here, omega square k. 1.1 I have left here. Yes, 1.1 I have to write. So here 1.1. So minus 1.1 here also, right? Minus 1.1. Yes, minus 1.1. Yes, minus 1.1. Please correct it. Minus 1.1 omega square k. So be careful while calculating, right? So minus 1.1 omega square, minus 1.1. This one, right? Then minus 1.1 here also I'll add it, 1.1. So here 1.1 I have to take, right here 1.1. So this 1.1 and this 1.1 they will get cancelled, right? So minus k by 11 I am getting. I hope this is correct now. Yes. Yes, it is correct. So it is minus k by 11. This is nothing but the coordinate of q. The coordinates of q means the intersection point, right? This is coordinates of q. So what is gain margin formula? I have written here. So I have called this as equation 1, right? Gain margin equal to 20 log of 1 by magnitude of OQ, right? Let me rewrite that formula. Gain margin is equal to 20 log of 1 by magnitude of OQ. So to the base 10. And what is gain margin? That is given this 6 decibels. So this formula I have taken in 6 decibels. Let me write it 6 dB, right? So 20 log of something, it will be in decibels. So yes, okay, fine. Then log of 1 by magnitude of OQ to the base 10. So 6 by 20. 6 by 20. 6 divided by 20. So I am getting 0.3. Next, 1 by magnitude of OQ is equal to 10 to the power of 0.3. 10 to the power of 0.3. So 10 to the power of 0.3. So I am getting 1.995. Okay, what is magnitude of OQ? Let me substitute here, right? Or else let me take this side. So magnitude of OQ, I'll take this side, and 1 divided by 1.995. So what is this magnitude of OQ? Let me write it. So O to Q, right? Q I am getting minus K divided by 11. O is origin. So it is magnitude of minus K by 11. Magnitude of minus K by 11. Minus K by 11. So 1 divided by 1.995. So magnitude means it is positive value. So K by 11 is equal to 1 divided by 1.995. Calculate the value of K. So K is equal to, take this level, 11 divided by 1.995. So I am getting K value as 5.513. So this is the value of K, right? Okay. You can check it. Yes, 5.514 or 513 I am getting. Is it fine? I hope you understood this. So in calculations, be careful. I have written here, but I have left 1.1. You're right. Okay. Thank you for helping. Okay. So we'll move to the next numerical. I hope you understood this numerical, right? Okay. Next we'll proceed. Okay, we'll proceed with the next numerical. The open loop transfer function of a unity feedback system is g of s, the same as previous. Determine the value of k, but here instead of giving gain margin, they have given phase margin. So we will make use of phase margin formula here, right, in order to determine the value of k. So g of s is equal to k divided by s into 1 plus 0.2s. So 1 plus 0.05s. Okay, this g of s is changing. I can keep it same as previous problem, and I can ask you that also in the next numerical it is there. So k divided by s into 1, the fine. So what is the value of k we want to determine, and given phase margin is 40 degree. So okay, we'll determine k. Okay, what is phase margin formula? It is equal to 180 degree plus angle of g of j omega into h of j omega at omega equal to omega gc. Here we are using gain crossover frequency omega gc. Is that fine? Okay. So phase margin is given. What is phase margin? It is 40 degree. Write it, 40 degree. It is equal to 180 degree plus angle of g of j omega into h of j omega at omega equal to omega gc. So therefore angle of g of j omega into h of j omega at omega equal to omega gc. What I am getting? 40 degree minus 180. Is it fine? 40 minus 180. 40 degree. So I am getting minus 140 degree. You take this side. So I am getting minus 140 degree. So call this as equation 1. Is it fine? So we know how to find out the angle, right? So angle of g of j. First we'll take angle of g of j omega into h of j omega. Is it fine? So we'll try to calculate angle of g of j omega into h of j omega. Right? At omega equal to omega gc, we'll substitute later. First we'll find out angle, right? So first let me write g of, replace s by j omega. Let me write it. So k divided by, it could have written here only. I don't have space, so I am writing here. Replace s by j omega. So 1 plus 0.2 s is j omega. Substitute. So similarly, you substitute for s here. 1 plus 0.05 s is j omega. Okay, now I have g of j omega in frequency domain. So now I want angle of g of j omega. So h of j omega they have not given. Leave it, right? It is 1. H of s is 1, right? So this it's optional, right? I know it is unity 1, right? So angle of k, numerator, it will 0 degree, right? 0 degree divided by angle of j omega, it is 90 degree. It is lying on that 90 degree, right? You know this, how to calculate. Then angle of this, tan inverse of imaginary part by real part. So tan inverse of 0.2 omega divided by 1, I will not write. So next, tan inverse of imaginary part 0.05 omega by 1. Tan inverse of 0.05 omega by 1, I will not write, right? Okay, next what I will be getting? Minus 90 degree, take it to numerator, minus tan inverse of 0.2 omega minus tan inverse of 0.05 omega. Yes. So angle this, let me substitute in equation 1. Whatever I am getting this one, angle of g of j omega, I will substitute here, right? So but what is omega? Omega equal to omega gc. Wherever omega is there, you write omega gc. That's all, right? So I'll substitute in equation 1. Substitute angle of g omega in equation 1. So we'll substitute this, right? Left hand side minus 90 degree minus tan inverse of 0.2 minus tan inverse of 0.2 omega gc. We are replacing omega by omega gc, that's all. Minus tan inverse of 0.05 omega. 0.05 omega gc. It is equal to what? Minus 140 degree. Okay, we will take this both on right hand side, but I will write it here. If I take it, it will be positive. So tan inverse of 0.2 omega gc plus tan inverse of 0.05 omega GC. You take this tan inverse both on that side, it will become plus. I am writing first this one, that is equal to minus 90. This if it comes this side, so it is minus 90 plus 140. Is it correct? So we are taking this to that side, minus plus 140, minus 90 plus 140. So I am getting 50 degree. So minus 90 plus 140, right? So I am getting 50 degree. Next, taking tan on both sides. So now it is mathematical steps, taking tan on both sides. Tan on both sides. So what is tan of a plus b formula? Can anyone tell? Tan of a plus b. Tan of a plus b formula, and can anyone tell what is tan of a plus b?
Tan A tan B divided by 1
Tan a
1
plus
plus
tan
tan
b.
A
Tan a plus tan b.
divided by 1 plus tan A tan B.
1 plus or 1 minus? 1 plus or 1 minus?
1 minus.
1 minus. 1 minus tan a into tan b. So tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Right? We will apply this formula taking tan on both sides. So this I will treat it as entire thing as a and this entire thing as b. So tan of a plus b. So tan a tan b. So tan a means tan of tan inverse of this quantity, means I will get this thing. Tan of tan inverse of 0.2 omega gc means 0.2 omega gc I will get. I am doing directly. If any doubts you can ask. This is tan a. Tan a means tan of tan inverse of 0.2 omega gc. So tan of tan inverse will get cancelled. 0.2 omega gc I will getting, right? Plus tan b. Tan b means tan of tan inverse of this quantity. So I will getting 0.05 omega gc. Tan a plus tan b divided by 1 minus tan a into tan b means this into this, right? So 0.2 omega gc into 0.05 omega gc. If any doubts you can ask, right? I hope you are getting 1 minus tan into well. Then tan on both sides. Tan of 50 degree. Tan of 50 degree will take, right? Tan of 50 degree. So let me write what I am getting. Tan of 50. So I am getting 1.192. 1917 means 192. I will round off, right? Okay, next we want to calculate omega gc, right? So let me add 0.2 plus 0.05. 0.2 plus 0.05. So 0.25 omega gc. I am getting 0.25 in the numerator omega gc divided by 1 minus 0.2 into 0.05. 0.2 into 0.05. 0.2 into 0.05. I am getting 0.01. 0.01 omega gc into omega gc, it is omega gc square. So that is equal to 1.192. So I want to calculate omega gc. We can calculate 0.25 omega gc. So take this quantity right hand side. So 1.192 into 1 minus 0.01 omega gc square. 0.25 omega gc is equal to, just multiply 1.192 into 1 is 1.192 minus 1.192 into 0.01. 0.01. So 0.0119. Let me stop here only. 119 omega gc square. 2 is there. Okay, let me write it. No problem. Omega gc square. So this is quadratic equation. What I am getting? Let me rewrite it. Let me take this side. It will become plus 0.01192. 0.01192 omega gc square. This I have taken this side plus 0.25 omega gc. This I have taken this side, right? This, then take this also, minus 1.192. Minus 1.192 equal to 0. Can I write this? If I am making any mistakes, please check it. This is plus, this is plus, this will be minus. Correct. Okay, you can solve using your calculator this quadratic equation. So I'll go to equation. Degree is 2. So value of A is 0.01192. Then value of B is 0.25. Then value of C is minus 1.192. So I am getting this values omega GC equal to 4. Then next another value I am getting minus 24.97. So we have to consider positive value. So considering positive value. Consider positive value. Why I should consider positive value? Anyone can answer? So always we should discard the negative value, right? So consider this negative value you will discard. So omega g is equal to 4 radians per second. Okay, we have found out omega gc, but our intention is to find out k. What is the value of k? So what we can do? So here, yes, we have angle of g of j omega, right? So here, angle of g of j omega, omega gc we came to know. We'll substitute here, right? One more thing, 1 minute. Just before proceeding, let me have a quick glance here. Okay, fine. This is 4 radians per second. And one more thing for this problem, at omega equal to omega gc, this condition we have to use. 1 minute. At omega equal to omega gc, gain crossover frequency, right? So we know this magnitude of g of j omega into h of j omega is equal to what? Can anyone tell what is this? At omega equal to omega gc, magnitude of g of j omega and h of j omega equal to what? Can anyone tell? Can anyone tell? Okay, I will make you answer. You can observe here at omega equal to omega gc. Observe this diagram. At omega equal to omega gc, here it will come, right? So what is the magnitude here? Magnitude of g of j omega into h of j omega equal to what? At omega equal to omega gc at point P, what is the magnitude? Look at it. This is unit circle, right? This is unit circle. So what is the magnitude here? 1, right?
0.
No, 1. Because see here, this is unit circle means, so minus 1, right? Everywhere the radius is unity. So here also it will be 1 only, right? So magnitude of j of j omega and h of j omega is equal to 1. At omega equal to omega gc at point P, right? So this please. So we'll make use of this. It is equal to 1. Right? Okay, fine. So what you told is correct, but it is in decibels. Magnitude is 0. Sorry, you told magnitude in decibels is 0. What you told is correct, but I am not taking in decibels, right? I hope whatever told is also right, but it is in decibels. 0 decibels you have to tell. Okay, fine. We will make use of this and equate it to 1. So what is magnitude of g of j omega? Let me write it here. G of j omega into once again. For my reference, I will write here g of j omega into h of j omega. So where is it? Yes, here. K divided by j omega into 1 plus 0.2 j omega +1 plus 0.05 j omega 0.05. I hope it is correct. Yes, this is g of j omega, right? Okay. Okay, I want magnitude. So magnitude of g of j means magnitude of k. So magnitude of k is k only. Then magnitude of j omega 0 plus j omega under root of 0 square plus omega square. It is omega, right? Next, so under root of magnitude of 1 plus 0.2 j omega under root of 1 square plus 0.2 omega square. So under root of 1 square is 1 plus, so 0.2 square. What is 0.2 square? 0.2 square. So let me come to the normal mode of calci. 0.2 square. 0.2 square it is 0.04. So 0.04. What is this? Omega square. Omega square. Next, magnitude of 1 plus 0.05 j omega under root of x square plus y square, right? So under root of x square is 1 square is 1 plus 0.05 square. 0.05 square. So I'm getting 2.5 into 10 to the power of minus 3. But omega square have to write, right? Okay, this is at omega equal to omega gc. So what is that? Omega equal to omega gc. What is that omega gc I got? It is 4 radians per second. We have to substitute. It is equal to 1. So we have taken magnitude, right? So substitute wherever omega is there. Omega gc, that is 4. You calculate it, right? K divided by, so 4 into under root of, so let me write it directly. I will not do separately. 4, fine, this is fine. Next, 1 plus 0.04 omega square. So 1 plus 0.04, 1 plus, let me open the bracket, 1 plus open bracket 0.04 into omega square. Omega square means 4 square, 16. 4 just 16. So I am getting 1.164, root of 1.164. So I am getting 1.28 from this one. So directly I will write 1.28 I am getting. Let me substitute this also and calculate. 1 plus open bracket 2.5 exponential minus 3 into omega square. Omega square means once again 16, right? 4 just 16. Let me close this. So I am getting 1.04, but root of 1.04. Take root of it. So I am getting 1.019. So this is equal to 1. Next, calculate k. K is equal to, so multiply all these things and multiply with 1. Take that side. So 4 into 1.28 into 1.019. So 5 point. So just you take this side. So I'll be getting into 1. That is 5.217. 5.217. You can check it. 5.22, right? 5.217. You can round it. 5.22, right? I hope you understood this numerical. Yes. Okay. Okay. I'll stop recording here only.